It's a question that haunts the restless lands of California. What if everything we thought we knew about the San Andreas Fault is about to change?
There's a new study that suggests the San Andreas fault line isn't the only one Southern California should be worried about.
Beneath the sprawling cities, lush vineyards, and golden hills of America's west coast, the ground is sending out signals no one expected. From Los Angeles to San Francisco, from the misty forests of the north to the sun-baked valleys of the south, seismic instruments have begun to record movements, subtle tremors, and new patterns that challenge the very foundation of what we thought possible. Scientists are warning of a hidden connection, one that could turn a local disaster into something far more widespread. For years, the big one meant a singular, catastrophic earthquake, a moment of intense but isolated chaos. But new science now asks, what if the real threat is more intricate, more unpredictable, and more devastating than we've ever imagined? As new research reveals possible geologic links between the notorious San Andreas and Cascadia fault zones, the everyday rhythms of life, family shopping, commuters on the endless highways, children at play, are set against a mounting geologic tension. Hundreds of feet below, the Earth's crust is slipping and straining toward a new and unsettling alignment. Seismologists describe the phenomenon of supershear earthquakes, faster, more violent, and extreme. Increasingly, hints emerge that two of the world's most dangerous faults may be acting in sync, poised for not just a single devastating quake, but something unprecedented. A sequence of megaquakes with the power to reshape the West Coast in ways never before witnessed. But what do these signals mean? And how close might we be to the breaking point? If the San Andreas and Cascadia faults are now interacting, are we all unwitting participants in an experiment scripted by the Earth itself? Chapter 1. Awakening. Faults. What happens when fault lines no longer play by the rules we set for them? For generations, the San Andreas Fault has loomed as the most infamous fracture in North America. A 1,200-kilometer-long geologic wound running from the Gulf of California north, slicing through the heart of the state, past Monterey's rugged cliffs and through sunlit farmlands, all the way to the green forests near the Oregon border. It is not only a boundary between tectonic plates, but between certainty and the unknown, a line etched both in stone and in the cultural psyche. But in recent months, timed with the change of seasons, as autumn's colors faded and Pacific storms battered the coast, new waves of seismic energy have rippled through research centers and monitoring arrays. These are not the familiar, creeping tremors that so often pass unnoticed beneath California's crust. Instead, scientists report sequences of microquakes, sudden slips, and energy pulses that move in surprising ways. At times, these ruptures accelerate beyond the usual seismic speeds, a phenomenon known as supershear. Once rare in the scientific record, supershear signatures now pepper the data with increasing frequency. In such quakes, the rupture front races faster than the surrounding seismic waves, releasing energy so suddenly that cities above have little time to react. This has altered the tone in scientific briefings. In October 2025, emerging headlines began to suggest a truth that until recently sounded more like science fiction, that the mighty San Andreas Fault and the darker, even less understood Cascadia subduction zone may no longer be isolated parts of the geologic puzzle. Research into unprecedented global seismic events underscores the possibility that a fracture at one site can affect another, potentially triggering a string of powerful quakes that span hundreds of miles. This is not the age-old myth of the big one, a single catastrophic break and shudder. Today, the apprehension lies in a world where one rupture awakens others, where once quiet fault lines are showing signs of acting in concert. If these new signals are a harbinger, then everything once thought impossible may in fact be building beneath our feet. Each step through the hills of Northern California, each tranquil night in the Oregon woods, might be a prelude to a seismic event unseen in recorded history. Chapter 2: A Bridge of Catastrophe. What if disasters don't stop at boundaries etched on a map? The classic image of the San Andreas Fault is a tidy line cleaving the landscape, a divide between California and the world beyond. Yet the Earth cares little for human maps. Deep underground, in thick darkness beyond human senses, the planet's workings are a tangled web of fractures, old stresses, and hidden pathways. Here, scientists are piecing together evidence of a new and potentially dangerous connection, a geologic corridor linking two titans, San Andreas and Cascadia. The Cascadia subduction zone lurks from Northern California through Oregon and Washington to British Columbia. For centuries, it has lain silent, stockpiling immense tectonic pressure. The last megaquake there, in the year 1700, unleashed a tsunami that crossed the Pacific, crashing on Japanese shores and imprinting a legacy in legends and written records. Few in modern times remember its force, yet the dangers it poses have become central to seismic risk planning. Now, researchers have detected signs of potential alignment between the northern reaches of the San Andreas and the southern edge of Cascadia. Carefully analyzed tremor sequences and subtle hints of crustal movement suggest these faults may not be acting entirely independently. Studies have raised the possibility that a quake in one region could trigger shifting in the other, a theory sometimes referred to as dynamic triggering or fault interaction. This new hypothesis is stirring anxiety in geological circles. Should a rupture begin beneath the coast near Mendocino, the notorious triple junction where three plates meet, its energy could pulse down the Cascadia zone and simultaneously destabilize the northernmost segment of San Andreas. If the faults are indeed interacting, what was once a regional risk could spill across state boundaries, affecting broad swaths of the west coast. Seismic arrays in both zones have recently recorded tremors, small but suspiciously synchronized. It is as if the continent itself is holding its breath, waiting for a signal. The warning? A chain of megaquakes that could inflict devastation with little precedent in modern California. If the data prove meaningful, it could signal the early stages of a complex system ready to cascade, a reality that ignores state lines and historical expectations alike. Chapter 3: Supershear, the speed of destruction. What happens when an earthquake outruns its very own warning? To grasp the new threat facing the West Coast, it is not enough to picture a larger earthquake. Instead, scientists are concerned about a different type of rupture, a supershear quake that moves so rapidly it effectively outpaces the destructive shockwaves it unleashes. Supershear earthquakes are among the most energetic events in Earth science. Imagine a rupture front slicing through rock not at the sedate pace of typical earthquakes, but moving so quickly it races ahead of its own seismic energy, like a sonic boom tearing through the landscape. Only a handful of such quakes have ever been recorded worldwide, but some recent tremors, including those in other global hotspots, fit the pattern more closely than once thought. Researchers note that the long, straight segments of the San Andreas, particularly in the north, are especially suited for such supersonic ruptures should the right conditions emerge. Studies, including analysis of catastrophic quakes in places like Myanmar, suggest the San Andreas could, under certain circumstances, support such rapid slip. Supershear ruptures produce exceptionally intense and focused shaking at the leading edge, greatly amplifying damage potential. In a worst-case scenario, destruction would unfold faster than warning systems can respond, Critical infrastructure, highways, railways, aqueducts, power lines that crisscross the fault could fail almost without warning. Importantly, new modeling and monitoring raise the possibility that if Cascadia and San Andreas are indeed interacting, supershear conditions could propagate from one fault zone into the next. Shaking would not only be stronger and more abrupt, but could also leap from region to region via stress transfer and fault coupling. In such an event, ferries, terminals, data lines and utilities stretched along the fault could be disrupted before warnings can reach the public. The implications are profound. Even with advanced monitoring networks and alert systems, a supershear quake would strain the bounds of preparedness. It poses the urgent question: are we entering an era where devastation arrives with brutally little warning, changing forever what it means to prepare for seismic disaster? Chapter 4: Signals in Sync. Can a continent truly shudder in unison? There are moments when science brushes up against instinct, a careful analysis paired with an uneasy hunch. Over recent months, those working along the West Coast's fault zones have seen such moments accumulate. Significant research has detected that two major fault systems, the San Andreas and Cascadia, appear to be showing patterns of timing together. While this does not mean the faults will definitely rupture together, it is an observation prompting serious study. To the naked eye, the landscape is serene. Rolling hills, towering redwoods, rivers tracing their ancient beds. Underground, however, modern seismic networks have mapped something unusual. Clusters of microquakes and tremor bursts occurring almost simultaneously on both faults. The effect creates a pattern that seems intentional. But whether it is coincidence or cause still sparks debate. Technological leaps, GPS arrays, borehole sensors, fiber optic cables snaking along fault lines have refined our ability to measure the tiniest crustal shifts, sometimes even as small as millimeters over months. What stands out is the frequency with which seismic signals in one fault are echoed or closely followed in the other. Some scientists propose tectonic pressures may now be redistributing along this newly hypothesized bridge, transferring stress and making synchronized ruptures more plausible than previously thought. The consequences, if proven, would be staggering. If a major rupture begins in one system, it could, through stress changes and seismic waves, trigger the other in short order. In such a scenario, California and the Pacific Northwest could experience not just one monster quake, but a rolling sequence. Shaking propagated from Portland to Palm Springs and beyond. Models are still being built to capture the full risk, but the warning signs are clear. Seismic synchronization is no longer just a theoretical curiosity. We may be seeing the early notes to a dangerous crescendo. Chapter 5: A chain reaction waiting to happen. Can one tremor set off a chain that shakes the very bones of a nation? New scientific models and accumulating field data are drawing a hard-to-ignore conclusion. The San Andreas Fault and Cascadia subduction zone, once seen as distinct, may operate in concert as neighboring actors in a complex seismic grid. Picture this. A sizable quake originates offshore at the Mendocino Triple Junction, the increasingly scrutinized point where the Pacific, North American, and Gorda plates meet. Its tremor bolts up the Cascadia zone, releasing energy centuries in the making, and in the process destabilizes the adjacent Northern California segment of San Andreas. Alarms blare through control rooms, alerts bounce across two nations, and the rupture, possibly moving at super shear speeds, extends devastation before news can spread. The alternative is equally chilling. If the southern San Andreas, the big one scenario, fires, The released energy may unload additional strain onto Cascadia, possibly priming it for a subsequent quake. Researchers now caution that the apparent fault alignment means any large event could become the first in a chain, each segment acting as a domino for the next. The Earth's crust is not organized by cities or counties. It moves according to physics, silent and indifferent. Each new tremor, no matter how small, could be the warning sign of what's to come. If this model proves correct, then we must prepare for a new era where disasters are not standalone, but sequential, where recovery from one is interrupted by the arrival of the next. Are we ready for a world in which even small events can potentially set off reactions on a massive scale? Is vigilance enough? Or does the very nature of seismic risk demand a rethinking of the systems, technological, engineering, and social, we put in place to withstand what could be a double or triple blow? Chapter 6. The lessons of the past, the warnings of the future. Does history echo enough for us to hear the footsteps of catastrophe approaching? The land has always rumbled in fits and bursts. A warning here, a lull there, followed by uneasy calm. Indigenous communities up and down the coast preserved oral histories recalling the sea rushing inland, forests vanishing into floodwaters, and the land rising and falling like breathing. When Cascadia last ruptured in January 1700, it spawned a tsunami colossal enough to strike even Japan, where centuries-old records describe devastated villages and mysterious receding tides. In recent California memory, the worst shakes often recall the Great San Francisco Quake of 1906, the Loma Prieta event in 1989, or Northridge in 1992-1994. Each caused heartbreak and upheaval, but each was merely a fragment of the fault's true capacity, a partial awakening, not the unleashed force long overdue. Today, scientists scour the seismic gap, an ominous quiet sometimes observed before violent quakes, much as it was prior to the 2011 Tohoku disaster in Japan. Suspicion grows that, just as with Cascadia and San Andreas, long periods bereft of major activity could foretell mounting risk rather than peace. Modern models, fueled by global data and technology, hint at a future where linked megaquakes, like those observed in theory in the latest research, are not only possible, but plausible. Against this backdrop, nearly every new tremor carries heightened significance, with the latest findings suggesting that even distant megaquakes, such as Myanmar's supershear event, can help forecast California's potential. It is clear that the past holds warnings, still not fully absorbed. Each signal, each lull, each trembling, demands we listen, prepare, and act, not only for a single big event, but for the possibility that the land's next warning may come in a sequence. Chapter 7. Tectonic Dominoes. If the Earth is a machine, what happens when all its gears turn at once? Seismic risk often feels abstract, something for future generations to contemplate, or a problem solved by building codes and temporary evacuations. But the question remains, what if multiple faults are now primed to move in sequence, with each segment's rupture acting as a lever for the next? Earth scientists now talk of tectonic dominoes. Each fault is not merely a slip zone, but a conduit for transferring stress, potentially igniting nearby faults in a chain reaction. If the San Andreas and Cascadia are linked, as emerging evidence and models suggest, then the risk turns from isolated disaster to compound catastrophe. Modern infrastructure, bridges, highways, aqueducts, utility corridors, has tied the West Coast together as never before. But these same networks are exposed in a multi-fault, multi-region scenario. Lifelines stretching from British Columbia to Southern California could become liabilities in the new era of linked disasters. Pipelines drawing water from distant basins, power flowing from mountain dams, and digital signals connecting millions, all could be interrupted in ways planners have barely begun to address. If a megaquake, especially one with supershear characteristics, strikes, immediate loss of power, water, and transit could ripple through tens of millions of lives. Bridges could shatter, highways crumple, and reservoirs fail, raising questions of not just recovery, but basic survival. Preparedness plans, long focused on the earthquake, may need wholesale revision should cascading events become the new norm. California's engineering and emergency plans have long been among the world's most advanced. But are we building for a single disaster, or for the possibility of several in swift succession?
Chapter 8. The Silent Countdown. Do the sensors whisper secrets before catastrophe bids us listen? As researchers shift their attention to these evolving threats, a sobering thought emerges. Even with unprecedented advances, global seismic networks, satellite geodesy, fiber optics, and real-time computing, the moment of disaster often remains knowable only in its aftermath. Massive volumes of data are analyzed daily from Vancouver to Los Angeles, with technology rendering the crust into a living, monitored system. Subtle surges, barely rated in public reports, are examined closely for their potential to hint at something bigger. Yet even this high-tech vigilance faces limits. Supershear quakes and cascading triggers are, by definition, extremely abrupt. The critical seconds once preserved by earthquake early warning systems may dwindle. In the scenario of a linked, rapid-fire sequence of megaquakes, any warning, even a matter of seconds, could be all that separates safety from calamity. Emergency planners are acutely aware of this new reality. Disaster scenarios are growing more complex, and the need for multidisciplinary preparation, public awareness, infrastructure hardening, community resilience has taken on fresh urgency. In the end, though, the key moment may still come with little or no warning, as the Earth's plates move only by their timetable, not ours. Is the next disaster already quietly forming, awaiting only the right nudge, picked up as a faint hum in distant instruments? Or does this period of preparation still offer an opportunity for adaptation, resilience, and hope?
Chapter 9. Across the Faultline of Tomorrow. If disaster is inevitable, is there still room for discovery? The story of the San Andreas and Cascadia is about more than looming threat. The relentless signals, the data streaming from instruments old and new, are also records of discovery. The Earth itself revealing its secrets, chapter by chapter. Each scientific breakthrough, every new piece of evidence suggesting fault interaction or supershear potential, expands not only our ability to predict, but our very understanding of the dynamic world beneath our feet. Scientists, engineers, and emergency planners are intensely focused on the clues emerging beneath California and the Pacific Northwest. Their work is urgent, but it's also the continuation of a grand human puzzle, seeking not only to warn, but to understand and adapt to the restless Earth. Each newly installed sensor, each refined model, is a step towards not only surviving the next great shake, but building a civilization resilient enough to thrive after it. The coming earthquake sequence, whenever it unfolds, will test not just buildings and bridges, but the limits of our preparedness, our curiosity, are to respond with knowledge gained rather than just memories of loss. And perhaps, as past disasters have shown, in the aftermath of shaking and upheaval, the most significant legacy will be deeper insight into how our planet works and how we fit into its ongoing story. So for now, we stand atop these shifting grounds, listening closely to the whispers of the planet. The signals grow clearer and more frequent, the data pile higher, and questions of readiness and resilience become more urgent. However, the true moment, when and how the Earth will once again assert itself, remains unwritten. As we scan, prepare, and listen, one question reverberates along every seismograph.
Every community gathering, every sleepless night. Are we ready for what the San Andreas, the Cascadia, and the living Earth itself are preparing to reveal next?